Okay, so we're going to translate this using this translate by vector tool right here. So I click on my shape, I click on a point, and let's say I want to translate this 3 units to the right. So I'll click on this and I see 1, 2, 3. Okay, so it's been translated 3 units to the right. Now let's say I want to translate this 2 units up. So I'll take my point and I'll translate it 2 units up. 1, 2. Okay, so this figure here has been translated 3 units to the right and 2 units up, and this will be my new figure. Okay, so that is translation. It's pretty simple. Okay, so now if we're talking about the next part, so we did translations, and so next is reflections. So let me show you how to do reflections on GeoGebra. So here you can reflect about a line, reflect about a point, reflect about a circle, and we're not going to do reflect about a circle. But we'll reflect about a line and about a point. So first we'll reflect about a line. So I just click on this figure and I'll reflect it across the y-axis. And there we go. So we have this figure and it's reflected there, and I can reflect it across the x-axis. There it is there. I can reflect it across the origin. Okay, so for that one, you have to reflect about a point. So I'll have to put a point right in the origin. And now I can reflect across the origin. Here. So now we have a beautiful picture. Symmetric picture. Okay, so that is reflection. So now let's try dilation. So dilation on this particular tool on Geogebra looks a little different than when you would actually do it by hand, because you will simply be multiplying each new point. For example, if I have the point, if I'm dilating by a factor of 2, and I have this point 2, 3, I'm simply going to multiply 2 by 2, which will give me 4. So my new x value will be 4. And multiply 3 by 2, which will give me 6. And so my new point for that one will be 3, 4, 6. If I do the same thing here, 4 by 2 is 8. 3 by 2 is 6. So that point will be 8 and 6. And then I have 5 here. Or 4 again is 8 by 5 is 10. And it's way off screen. I'll have to change it later. So let me just move up just a bit so we can see. Probably shouldn't have connected those dots. Okay, so let's try it again. So we knew that this new point was 4 by 6. And this new point was 8 by 6. And then we had 8 by 10. And then this point here is, so 2 times 2 is 4. 6 times 2 is 12. So when I dilate this figure here by a factor of 2, I'm simply multiplying each point by 2, and I should have this. So let's check and see if it looks like how they would have done it. So this one you have to dilate by a point. So I want the factor to be 2. And if I were to line up my new figure with the one I created, I see they match up. Okay, so these two figures have been dilated by a factor of 2. And if I were to dilate, let's try my little one, this one here. Let's try dilating this by a factor of 0.5. And I should expect a smaller figure. And there it is. I have a smaller figure. Each point, instead of being multiplied by 2, has been multiplied by 0.5, which cuts each point in half, pretty much. So this is half, not quite half, a little less than half, but each point is half of what the original point was. Okay, so there we have dilation. And last but not least, let's talk about rotation. I guess I'll use this figure since it's here. So we're going to rotate this guy. So again, I go back to this tool here, rotate around the point. So I want to rotate it around my origin. So I have my point there already. So I'm going to rotate this figure around the origin by a factor of 90 degrees. So we should see this in quadrant 2 here. Okay, and there we are. Let me just delete this little point there. Okay, so we have rotated our original figure by 90 degrees, and I can see that this line corresponds by 90 degrees to its new point. This point corresponds by 90 degrees to this point, and so on and so forth. Okay, so where we had 2 and 3, 2, 3 here, we should have -3 and 2. Okay, so it all corresponds. Let's try rotating it by a factor of 180. Okay, so we end up all the way over here. Okay, let's try again. This time I'm going to say clockwise by a factor of 90. So I should end up in the 4th quadrant. There we go. So now we have this really cool picture here of this one figure rotated around. Alright, so I want you to go ahead, go to Geogebra, and play around with some figures, rotate them around, dilate them, translate them, kind of go through all the transformations that we talked about in this video, and work on the worksheet provided.